Hello, let's go through lesson 20 and some of these practice problems. So question 1 says, two billiard balls collide before the collision. So we're going to talk about before the collision and after the collision. Before the collision, ball A moves with a velocity of 4 meters per second. So we have mass times velocity in each box. We know that it is moving 4 to the right. That is going to be positive 4. Ball 0 is at rest. Its velocity is 0. Okay, we don't know what their mass is yet. We're going to continue to read. After the collision, ball A comes to a complete stop. What is the velocity of ball B after the collision? The mass of each ball is 0.16 kilograms. So I know I have my mass, 0.16, and I have my mass, 0.16. All right, I'm going to multiply these two values together, and I'm going to get 0.64 kilogram meters per second. And anything times 0 is 0. When I add my momentums together to get the total momentum of my system, 0.64 plus 0 is 0.64. Let's talk about after the collision. After the collision, ball A comes to, let's do our mass and our velocity. Our mass is 0.16. The mass of the object is not changing. Its velocity comes to a stop, so its velocity is 0. In this case, again, the mass is 0.16. And it says, what is the velocity of ball B? We don't know, right? This is the question. All right, I can't solve for this. I don't know what this is, but I can do this. This equals 0. So I have 0.16 V. All right, so my two momentums added together. And now I have an equation. I have my before momentum is equal to my after momentum. Now, because I had plus 0, I'm just going to leave that off. And I'm going to have 0.64 is equal to 0.16 times my velocity. To solve for velocity, to get it by itself, we have to divide, because it's the inverse operation. 0.16, whatever I do to one side, I have to do to the other. And when I put this in the calculator, I get 4. 4 is equal to my velocity, 4 meters per second. Let's go on to question 2. A 3,000 kilogram truck, so our object is a truck, with a velocity of 10 meters per second hits a parked car. So we have our other object is a car. Let's go through and let's put in our masses and our velocities for each one. Our truck, it is a 3,000 kilogram truck, and it is traveling at 10 meters per second for a momentum of 30,000. Our car is 1,000 kilograms. It hits a parked 1,000 kilogram car, and it says parked car, that means its velocity is 0. Anything times 0 is 0. So our total momentum of our system is 30,000. We know that whatever we have on one side, we have on the other. The impact, so this is after our collision, the impact causes the 1,000 kilogram car. Of course, our truck still weighs 3,000. To be set in motion at 15 meters per second. So we know the velocity of the car is 15 meters per second. Assuming that momentum is conserved during the collision, what's the velocity of the truck? So we do not know the velocity of the truck. So what do we know? I do not know my momentum of my total system. So but I do know that it's 3,000 V. It's 3,000 times V. I do know that 1,000 times 15 is 15,000. And I know that when I add these two momentums together, I get 30,000. So I'm going to go 15,000. And now I have my algebraic equation. Let's move this down here. 30,000 is equal to 3,000 V, the momentum of my first object, my truck, plus the momentum of my car. So I have a constant expression, I have a variable expression, and I have a constant. I need my constants on one side, my variable expression on the other. Plus 15,000, I'm going to get rid of this 15,000 from this part. Whatever I do over here, I'm going to do over here. 30,000 minus 15,000, I'm left with 15,000. So I'm left with my momentum of 15,000 is equal to the 3,000 kilogram mass times the velocity. What this means is I have my momentum of my truck is equal to the mass of the truck times the velocity of the truck. And now we're going to solve for velocity. To get V by itself, we're going to use the inverse operation. Set 3,000 times V, we're going to divide by 3,000. Whatever we do to one side, we do to the other, and 15,000. So V is equal to 15,000 divided by 3,000, 5,000, oops, nope, 5. 15,000 divided by 3,000 is 5 meters per second. Let's look at number 3. We can either use a table or we can go straight to an algebraic equation. I'm going to show both ways to show how they work. A red cart collides with a blue cart. So I have my two objects. We have our before and we have our after collision. An 8 kilogram red cart moving at 48 meters per second to the right collides with a 4 kilogram cart, blue cart, traveling at 12 centimeters per second to the right. We're going to do our befores. 8 times 48. $384 plus 4 times 12. Oops, we're going to go 304 plus 48. 432. Our total momentum of both objects before the collision is 432. That's also going to be 432. So whatever we get here is going to be equal to this. After the collision, the red cart, which it weighs 8, is moving 24 centimeters per second. And that's going to be 192. Our 4 kilogram blue cart, what is the velocity of the blue cart after collision? Well, we don't know. So 4 times v is 4v. We do know that if I add these two together, we're going to get our total momentum, which is equal to 432. And so we now have our algebraic expression. 432 equal to 192 plus 4v. Constant expression, variable expression. We have to get this constant over here. So we're going to subtract 192 away. We're going to subtract 192, which is the momentum of our red cart. It's only going to leave us with everything for our blue cart. So 432 minus the cart, minus the red cart, is going to leave us with 240, which is our momentum of our blue cart, which is equal to the mass of the cart times the velocity of the cart. We're going to divide by 4. Whatever we do to one side to get v by itself, whatever we do to one side, we do to the other. And so we're going to get 240 divided by 4, which is going to equal 60 centimeters per second, is equal to our velocity. Let's look at question 4. This one, we're going to go directly with the equation. Nope, we'll use the table. Our objects, a red box and a blue box. We have our before and our after. Let's look at these. A 5 kilogram red box, so we have mass times velocity. We know it is 5 kilograms. I could put 5 in right away for both the before and the after. The mass is not changing. A 3 kilogram blue box. I can put that in for the mass of before and after because the mass is not changing. A 5 kilogram red box and a 3 kilogram blue box collide on a frictionless surface. Before the collision, the velocity of the red box is 10 meters per second to the right, and the velocity of the blue box is unknown. So we have slightly different equation, but it will still work out the same. After the collision, the box moves 3.5. Red box moves 3.5 meters per second to the left. That means we have to have a negative because it's going to the left. And the blue box moves 14.5 meters per second to the right, so it will be positive. Calculate the initial velocity of the blue box. I am going to do some math magic. I'm just going to calculate off the screen. I'll be back in a second. The math magic has happened. What did I do? I multiplied 5 times 10 to get 50. 3 times v is 3v. I don't know what they are because this is a constant and a variable and I can't add them, but I do know that added together they're equal to the momentum over here. Over here I multiplied these two numbers, and added them together to get my total momentum of my collision momentum after the collision. So I have my algebraic equation. 50 plus 3v equals 26. I have a constant, a variable expression, and a constant. I'm going to get rid of this constant. And so I have all my constants on one side. 3v, so 3v, right? So the mass of the blue cart times its velocity is equal to negative 24. kilogram meters per second. I'm going to divide both sides by 3. Velocity is equal to negative 8 meters per second. Negative 8 means we're going 8 meters per second to the left. So what's the story that it tells us? This red box was moving to the right. It hit the blue box and then began moving backwards to the left at much less velocity than it started at. This blue box started going at negative 8 meters per second to the right, hit the red box, which was larger, and afterwards was moving back with a velocity of 14.5 meters per second. So it's moving to the right. So this is the story that it tells me. That they came together, they bounced off each other, and they moved back away. Again, because it's an elastic collision. Question number 5. This one we need to find where the mistakes are. So let's read through carefully. A, 0.12 steel ball. Kilograms, let's check. 0.12 kilogram steel ball. 0.112, 0.112, that's correct. Moving at 1.54 meters per second. Let's check. 1.54 meters per second. Strikes a second steel ball with the same mass. Same mass. 0.112, those are correct. Moving in the opposite direction. Oh, well, if this is a positive 1.54 and this is moving in the opposite direction, that means it has to be negative. Let's check the, oh, nope. We got a problem. That should be negative. The second steel ball, let's continue. The second steel ball rebounds and travels, bounces, and travels at 0.72 meters per second after the head-on collision. So it rebounds, it means it starts traveling the other way. So that's correct. So this box is correct. This box is correct. This is our mistake. Determine the velocity of the steel ball. So what's the problem? The problem is this should be negative. If this is negative, then that's going to change this whole value. So that's going to make that negative. When we add these two together, that's going to change this. I did a little math magic to save time, and this would be the new momentum. We would make these equal to each other, and we would go ahead and solve for V.